Okay, so we're up to the final module, which is, of course, module 14, network automation from ENSA. Okay, so what's in this chapter? So there's an automation overview, then we're going to look at the different data formats that are available. We'll look at application programming interfaces or APIs. We'll look at REST in particular, how you do the communications there. And then we'll look at configuration management tools, and then IBM and Cisco DNA Center. Okay, so automation. So, so of course, automation certainly has its benefits. So machines can work 24 hours a day without breaks, which results in greater output. They provide a more uniform output or product. Automation allows the collection of vast amounts of data that can be quickly analysed to provide information which can help guide an event or process. Robots are used in dangerous conditions such as mining, firefighting, and cleaning up industrial accidents. This reduces the risk to humans. Under certain circumstances, smart devices can alter their behaviour to reduce energy usage and make a medical diagnosis and improve automobile driving safety. All right, so many devices now incorporate smart technology to help to govern their behaviour. This can be as simple as a smart appliance lowering its power consumption during periods of peak demand, or as complex as a self-driving car. Whenever a device takes a course of action based on an outside piece of information, then that device is referred to as a smart device. Many of the devices that we interact with now have the word smart in their names. This indicates that device has the ability to alter its behaviour depending on its environment. In order for devices to think, they need to be programmed using network automation tools. Okay, so data formats. So data formats are a simple way to store and exchange data in a structured format. One such format is HTML or hypertext markup language. So it's a standard markup language for describing the structure of web pages. There are some common data formats that are used in many applications, including network automation and programmability. And so there's JavaScript object notation or JSON. There's extensible markup language or XML, and there's YAML, which is YAML 8 markup language. The data format that is selected will depend on the format that is used by the application, the tool or script that you are using. Many systems will be able to support more than one data format, which allows you to choose your preferred one. So data formats have rules and structure similar to what we have with programming and written languages. Each data format will have specific characteristics. Syntax, which includes the types of brackets used, so square, round, and ellipses, and the use of white space or indentation, quotes, commas, and more. How objects are represented, such as characters, strings, lists, and arrays, and then key and value pairs, how they're represented. And so the key is usually on the left side and it identifies or describes the data, and the value on the right is the data itself and can be character, string, number, list, or another type of data. So key would be name, and then the value would be John Smith. And so, all right, so some examples below, but we'll get into more examples later. And so here are some examples of JSON, YAML, and XML. And so they have their similarities, they have their differences, but yeah, they all can do very similar jobs. So JSON is a human-readable data format used by applications for storing, transferring, and reading data. It's a very popular format used in web services and APIs to provide public data. This is because it's easy to parse and can be used with most modern programming languages, including Python. So, so we're going to compare the iOS output above with the JSON format, which of course is on the right. Notice that each object, each key and value pair is a different piece of data about the interface, including its name, a description, and whether the interface is enabled. And so, I've got the overall title here of the interface, and then we've got the name of the interface, and then we've got the description that's been entered. Is it enabled, true, and IP addresses and masks and all kinds of things like that. as you can see, we use brackets to open and close these things, and yeah, to give it a bit of order and structure. Okay, so the syntax rules. These are some of the characteristics. It uses a hierarchical structure and contains nested values. It uses braces to hold objects and square brackets to hold arrays. Its data is written as key value pairs. With JSON, the data known as an object is one or more key value pairs enclosed in braces. The syntax for a JSON object includes keys must be strings within double quotation marks. Values must be a valid JSON data type, be that string, number, array, boolean, null, or another object. Keys and values are separated by a colon. Multiple key value pairs within an object are separated by commas. White space is not significant. Okay, at times a key may contain more than one value. This is known as an array. An array in JSON is an ordered list of values. Characteristics of arrays in JSON include the key followed by a colon and then a list of values enclosed in square brackets. The array is an ordered list of values. The array contains multiple value types, including a string, a number of booleans, objects, and another array inside of the array. Each value in the array is separated by a comma. And so, for example, here a list of IPv4 addresses might look like the following output. The key is addresses. Each item in the list is a separate object separated by braces. The objects are two key value pairs, an IP address and a subnet mask, and then separated by a comma. The array of objects is the list, is also separated by a comma following the closing brace for each object. And so you've got addresses here, and then you've got this IP address and mask, and then you've got this IP address and mask, and this IP address and mask. As you see, so you've got the start of the array here, end of the array there, and then you've got these three entries in the array and separated by commas. And of course, each one is delimited by the braces. Okay, so YAML is another type of human readable data format used by applications for storing, transferring and reading data. Some of the characteristics of YAML include it is like JSON and considered a superset of JSON. It is a minimalist format, making it easy for both read and write. It uses indentation to define its structure without the use of brackets or commas. So some examples here. And so again, looking at the same interfaces information, we have a name, a description, and then a Boolean for enabled true, and then the addressing information and the like. And so, of course, that's on the left, and on the right, how it looks with YAML. And so it certainly is a lot easier to read in the YAML, isn't it? So anyway, similar to JSON, a YAML object is one or more key value pairs. Key value pairs are separated by a colon without the use of quotation marks in YAML. A hyphen is used to separate each element in the list. So instead of the commas, we've got the hyphens. Okay, so XML is one more type of human readable data format used to store, transfer and read data by applications. Some of the characteristics of XML include it is like HTML, which is standardized markup language for creating web pages and web applications. It is self-descriptive, so you have a tag, then the data, then the close tag. But with XML, there are no predefined tags, and so you can just do whatever, however you wish to describe it. And so, of course, XML objects are one or more key value pairs with the beginning tag used as the name of the key. And of course, you just put the slash in front of the key to close that value. And so the output shown shows the same data for Gigabit Ethernet 2 formatted as an XML data structure. Notice the values are enclosed within the object tags. In this example, each key value pair is on a separate line and some lines are indented. This is not required, but it is done for readability. The list uses separate instances of tag and then slash tag for each element in the list. The elements within these repeated instances represent one or more key value pairs. And so you've got IETF interface, And then you've got the close down here. And so, of course, these are all contained within it. And so then you've got its name, end of name, description, end of description, enabled, enabled, and so on. So then you've got IPv4 addresses, and then away you roll. So, all right. So APIs, or Application Programming Interface, is a software that allows applications to access its data or services. Other applications access its data or services. It is a set of rules describing how one application can interact with another, and the instructions to allow the interaction to occur. The user sends an API request to a server asking for specific information and receives an API response in return from the server along with the requested information. So an API is similar to a waiter in a restaurant, as shown in the figure before. So you have the user, and then you have the waiter that sort of is what moves the messages from the user to the kitchen and then back again. So the API is like that. All right, so an example. To really understand how APIs can be used to provide data and services, we will look at two options for booking airline reservations. The first option uses the website of a specific airline. Using the airline's website, the user enters the information to make a reservation request. So, departure and destination, dates and times and things like that. The website interacts directly with the airline's own database and provides the user with information matching the user's request. And so you get the output down there in part 4. While a travel, I've got the name. So a travel site can access the same information, not only from a specific airline, but from a variety of airlines. And so it's like Webjet or something like that. And so travel agent. In this case, the user enters a similar reservation information, but the travel service website interacts with various online airline databases using APIs provided by each airline. And so the travel services uses each airline API to request information from that specific airline and then displays the information from all the airlines on its web page. The API acts as a kind of messenger between the requesting application and the application on the server that provides the data or service. The message from the requesting application to the server where their data resides is known as an API call. And so there are different types of APIs, and so there are open, internal and partner APIs. So open APIs, or public APIs, are publicly available and can be used with no restrictions. Because they're public, many API providers require the user to get a free key or token prior to using the API. This is to help control the number of API requests they receive and process. With internal or private APIs are used by an organisation or company to access data and services for internal use only within the company. An example of an internal API is allowing authorised salespeople access to internal sales data on their mobile devices. And then partner APIs are where used between one company and others, be they partners or contractors or whatever, to facilitate business between them. The business partner must have a license or other form of permission to use the API. A travel service using an airline's API would be an example of that. A web service is a service that is available over the internet using the World Wide Web. There are 4 types of web service APIs. So there's SOAP, or Simple Object Access Protocol. There's REST, which is representational state transfer. There's Extensible Markup Language Remote Procedure Call, or XML RPC. And there's JSON RPC. And so basically, SOAP's been around for a long time. So is XML RPC. REST and JSON are a little newer, but yeah, so they all have their advantages and disadvantages. All right, so REST, which is one that we'll on that list there. So web browsers use HTTP and HTTPS to request or get a web page. If successfully requested with the HTTP status code of 200, web servers respond to GET requests with an HTML coded web page. Simply stated, a REST API is an API that works on top of the HTTP protocol that defines a set of functions developers can use to perform requests and receive responses via HTTP protocol GET and POST. Conforming to the constraints of the REST architecture is generally referred to as being RESTful. An API can be considered RESTful if it has the following features. And so client server, the client handles the front end and the server handles the back end. Either can be replaced independently of the other. It's stateless. No client data is stored on the server between requests. The session state is stored on the client only. And cacheable, clients can cache responses to improve performance. Okay, so RESTful web service is implemented using HTTP. It's a collection of resources with 4 defined aspects. So you have a base uniform resource identifier, such as example.com resources. The data format supported by the web service. This is often JSON, YAML or XML, but could be any other data format that is a valid hypertext standard. The set of operations supported by the web service using HTTP, and the API must be hypertext driven. RESTful APIs use common HTTP methods, including post, get, put, patch, and delete. As shown in the table, these correspond to RESTful operations, which are create, read, update, or delete, and they call that CRUD anyway. Web resources and web services such as RESTful APIs are identified using a URI. A URI is a string of characters that identifies a specific network resource. A URI has 2 specializations. So you can either have a URN, which is your uniform reverse name, or URL, which of course is the uniform resource locator. And so basically the major difference between the two is that you just have the protocol extra on the URL. And so much like you have HTTP in your web browser. And so these are the parts of the URI that, so HTTPS of course is the protocol, then the host name, www.example.com is the host name, and then you've got the path within the web page, web server to actually get the page, and then the fragment is a page number. So in RESTful web service, a request made to a URI will elicit a response. The response will be a payload, typically formatted in JSON, but could be HTML, XML, or some other format. The figure shows the URI and MapQuest directions API. The API request is for directions from San Jose, California to Monterey, California. So I think it's explained in more depth in the next slide. Yes, it is. And so, of course, basically, we identify the API server, of course, is with the host name there. Resources specifies the API that is being requested, and so we're using MapQuest here. The query specifies the data format, and so we're using JSON. And then the key is for authorization, and so we're just using key as a key here because it's an example. And so with parameters, of course, that's the information for your search. And so, of course, we're going from San Jose to Monterey. And so in a RESTful request, many RESTful APIs include public APIs and require a key. The key is used to identify the source of the request. Here are some reasons why an API provider may require a key: to authenticate the source, to make sure they are authorized to use the API, to limit the number of people using the API, to limit the number of requests per user, to better capture and track the data being requested by users, and to gather information on the people using the API. Note, the MapQuest API does require a key. Search the internet for URL to contain a MapQuest key. Use the search parameters developer.mapquest, and you can also search the internet for current URL that outlines the MapQuest privacy policy. All right, so RESTful API applications. Many websites and applications use APIs to access information and provide service for their customers. Some RESTful API requests can be made by typing in the URI from within a web browser. And so the MapQuest directions API is an example of this. But they can be made in many other ways. And so from a web developer site, often maintain websites that include information about the API, parameter information, and usage examples. These sites may also allow the user to perform an API request within the developer web page by entering the parameters and other information. This Postman is an application for testing and using REST APIs. It contains everything required for constructing and sending REST API requests, and including entering query parameters and keys. Python APIs can also be called from within a Python program. This allows for possible automation, customization, and app integration of the API. The network operating systems using protocols such as netconf and restconf, network operating systems are beginning to provide an alternative method for configuring, monitoring, and management. All right, so management tools. So traditional network configuration, of course, is where you have your network devices being configured by an administrator using the command line interface. Whenever there is a change or new feature, the necessary configuration commands must be manually entered on all of the appropriate devices. This becomes a major issue on large networks or with more complex configurations. So after that, we've actually had SNMP, so Simple Network Management Protocol, lets administrators manage nodes on an IP network with Network Management Station. And so network administrators use SNMP to monitor and manage network performance and find and solve network problems and perform queries for statistics. It's not typically used for configuration due to the security concerns and difficulty in the implementation. You can also use APIs to automate the deployment and management of network resources instead of manually configuring ports, access lists, QoS, and load balancing policies. You can use tools to automate your configurations. So automation, so we are rapidly moving away from a world where network administrator manages a few dozen network devices to one where they are deploying and managing a great number of complex network devices, both physical and virtual, with the help of software. This transformation is quickly spreading to all places in the network. There are new and different methods for network administrators to automatically monitor, manage, and configure the network. These include protocols and technologies such as REST, Ansible, Puppet, Chef, Python, JSON, XML, and more. Okay, so configuration management tools make use of RESTful API requests to automate tasks and can scale across thousands of devices. These are some characteristics of the network that administrators benefit from automating. So software and version control, device attributes such as names, addressing, and security, protocol configurations, and ACL configurations. Configuration management tools typically include automation and orchestration. Automation is when a tool automatically performs a task on a system. Orchestration is arranging of the automated task that results in coordinated process or workflow. Okay. So the tools that we're going to talk about today are Ansible, Chef, Puppet, and SaltStack. The goal of these tools is to reduce the complexity and time involved in configuring and maintaining a large-scale network infrastructure with hundreds or even thousands of devices. These same tools can benefit smaller networks as well. So they all come with their API documentation for configuring RESTful API requests. All of them support JSON and YAML, as well as other data formats. The following table shows a summary of comparison of the major characteristics of Ansible, Puppet, Chef, and SaltStack configuration management tools. And so basically, they have Python is pretty regular, but they've got their other programming languages. Are they agentless or not? And so some are one, some are the other, and some are both. How are devices managed? And so they have any device can be a controller, and then the other ones have got their own tailor-made tools. And what is created by the tool? A playbook, a cookbook, and a manifest, and a pillar. A pillar of salt. Oh, God. Anyway, so IBN and Cisco DNA Center. We're getting towards the end, thankfully. So IBN is intent-based networking and is an emerging industry model for the next generation of networking. It builds on software-defined networking and transforming a hardware-centric and manual approach to designing and operating networks to one that is software-centric and fully automated. Business objectives for the network are expressed as intent, and then IBN captures the business intent and uses analytics, machine learning, and automation to align the network continuously and dynamically as business needs change. And so it captures and translates business intent into network policies that can be automated and applied consistently across the network. Okay, so Cisco views IBN as having three essential functions: translation, activation, and assurance. These functions interact with the underlying physical and virtual infrastructure as shown in the figure. And so translation is where the function enables the network administrator to express the expected networking behavior that will best support the business intent. Activation is where the captured intent then needs to be interpreted into policies that can be applied across the network. The activation function installs these policies into the physical and virtual network infrastructure using network-wide automation. And then assurance is continuously checking that the expressed intent is honoured by the network at any point in time. The assurance function maintains a continuous validation and verification loop. So always monitoring what's going on. From the perspective of IBN, the physical and virtual network infrastructure is a fabric, an overlay that represents the logical topology used to virtually connect to devices. The overlay limits the number of devices the network administrator must program and provides services and alternate forwarding methods not controlled by the underlying physical devices. The overlay is where the encapsulation protocols like IPsec and CAPWAP occur. Using an IBN solution, the network administrator can use policies to specify exactly what happens in the overlay control plane. Notice that how the switches are physically connected is not a concern of the overlay. All right, so the underlay is the physical topology that includes all hardware required to meet the business objectives. The underlay reveals additional devices and specifies how these devices are connected. Endpoints such as the servers in the figure access the network through layer 2 devices. The underlay control plane is responsible for simple forwarding tasks. Okay, so Cisco's digital network architecture, or DNA, implements the IBN fabric using Cisco DNA. And so the business intent is securely deployed into the networking infrastructure, the fabric. The Cisco DNA then continuously gathers data from the multitude of sources, so devices and applications, to provide a rich context of information. This information can then be analysed to make sure the network is performing securely at its optimal level and in accordance with business intent and network policies. Okay, so what kind of solutions do we have? So we've got SD Access, which is first intent-based enterprise networking solution built using Cisco DNA. It uses a single network fabric across LAN and wireless LAN to create a consistently highly secure user experience. It segments user, device and application traffic and automates user access policies to establish the right policy for any user or device with any application across the network. And so the benefits, it enables business access in minutes for any user or device to any application without compromising security. So SD-WAN, it uses a secure cloud-delivered architecture to centrally manage WAN connections. It simplifies and accelerates delivery of secure, flexible and rich WAN services to connect data centers, branches, campuses and co-location facilities. So it delivers a better user experiences for applications residing on premises or in the cloud. It achieves greater agility and cost savings through easier deployments and transport independence. Okay, so DNA assurance is used to troubleshoot and increase IT productivity. It applies advanced analytics and machine learning to improve performance and issue resolution and predict to ensure network performance. It provides real-time notification for network conditions that require attention. And so it allows you to identify root causes and provides suggested remediation for faster troubleshooting. It provides an easy to use single dashboard with insights and drill down capabilities. And so machine learning continually improves network intelligence to predict problems before they occur. All right, so DNA security is used to provide visibility by using the network as a sensor for real-time analysis and intelligence. It provides increased granular control to enforce policy and contains threats across the network. And so it reduces risk and protects your organisation against threats, even in encrypted traffic. So gain 360-degree visibility through real-time analytics for deep intelligence across a network. So there's lower complexity with end-to-end security. Okay, so the DNA Center is foundational controller and analytics platform at the heart of the Cisco DNA. It supports the expression of intent for multiple use cases, including basic automation capabilities, fabric provisioning, and policy-based segmentation in the enterprise network. Cisco DNA Center is a network management and command center for provisioning, configuring network devices. It is a hardware and software platform providing a single pane of glass or single interface that focuses on assurance, analytics, and automation. So DNA Center interface launch page gives you an overall health summary and a network snapshot. From here, the network administrator can quickly drill down into areas of interest. And so we have menus across the top of the page. And so there's 5 main areas. There's design, policy, provision, assurance, and platform. So design is how you model your entire network from sites and buildings to devices and links, both physical and virtual, across campus, branch, WAN, and cloud. So policy is to automate and simplify network management, reducing cost and risk while speeding rollout of new and enhanced services. So provision provides new services to users with ease, speed, and security across your enterprise network, regardless of network size and complexity. Assurance is proactive monitoring insights from the network, devices, and applications to predict problems faster and ensure that policy and configuration changes achieve the business intent and the user experience you want. And then platform uses APIs to integrate with your preferred IT systems to create end-to-end solutions and add support for multi-vendor devices. Okay, there is the end of the module. So just a bit of a rehash. So automation is any process that is self-driven, reducing and potentially eliminating the need for human intervention. Whenever a course of action is taken by a device based on an outside piece of information, then that device is a smart device. For smart devices to think, they need to be programmed using network automation tools. Data formats are simply a way to store and interchange data in a structured format. And so common data formats that are used in many applications across network automation and programmability are JSON, XML, and YAML. Data formats have rules and structure similar to what we have with programming and written languages. An API is a set of rules describing how one application is going to interact with another and the instructions to allow the interaction to occur. You have open or public APIs. As the name suggests, they're publicly available. Internal private ones are used only within an organisation, and partner ones are used between companies like business partners and the like. There are 4 types of web services, APIs, and so there's SOAP, REST, XML RPC, and JSON RPC. So a REST API defines a set of functions developers can use to perform requests and receive responses via HTTP protocol, such as GET and POST. Conforming with the constraints of REST architecture is generally referred to as being RESTful. RESTful APIs use common HTTP methods, including POST, GET, PUT, PATCH, and DELETE. These methods correspond to RESTful operations of create, read, update, and delete, or CRUD. Web resources and web services such as RESTful APIs are identified using a URI, and it has 2 specializations, so URN or URL. In a RESTful web service, a request made to a resource URI will elicit a response. The response will be a payload typically formatted in JSON. The different parts of an API request are API server, resources, and query. Queries can include format, key, and parameters. There are now new and different methods for network operators to automatically monitor, manage, and configure the network. These include protocols, technologies, such as REST, Ansible, Puppet, Chef, Python, JSON, XML, and more. Configuration management tools use RESTful API requests to automate tasks and scale across thousands of devices. Characteristics of the network that benefit from automation include software and version control, device attributes such as names, addressing, and security, protocol configurations, and ACL configurations. Configuration management tools typically include automation and orchestration. So orchestration is the arranging automated tasks that results in coordinated process or workflow. IBM builds on SDN, taking software-centric, fully automated approach to designing and operating networks. And so Cisco views IBM as having 3 essential functions: translation, activation, and assurance. The physical and virtual network infrastructure is a fabric. The term fabric describes an overlay that represents the logical topology used to virtually connect to devices. The underlying network is the physical topology that includes all hardware required to meet business objectives. So Cisco implements the IBM fabric using Cisco DNA. The business intent is securely deployed into the network infrastructure or the fabric. It then continuously gathers data from the multitude of sources, so devices and apps, to provide a rich context of information. So DNA Center is a network management and command center for provisioning and configuring network devices. It is a single interface, hardware and software platform that focuses on assurance, analytics, and automation. There's the logo. Last module of the last course for CCNA. Well, that's it. We're done. I'll see you later. Have a good one.